All right, this is picking it up on chapter 2, part 2. And we left off with conversion factors. So a conversion factor, this is in your textbook, is a ratio derived. So the ratio is in a fraction. See that? 4 quarters equals $1, and that equals 1 because they equal each other. So it's 1. And these are used to convert from one unit to the other. So they're really helpful, and they're used a lot in chemistry because we might have to convert from grams of a reactant to grams of a product, or moles of a reactant to moles of a product. So it's used a lot, so you have to get this. So these are the conversion factors, and this one is a fourth of a dollar equals a quarter. So you're probably more comfortable seeing whole numbers, not decimals, fractions. So I would use whatever unit is larger, you make that 1. So a dollar is larger than a quarter, so you make it 1. If you were using, excuse me, if you were using like 1 meter and 1 centimeter, you would use 1 for the meter and 1/10 for the centimeter. 1/100th. Whoops. So instead of using 1 centimeter, then you would use, so 1 meter and 100 centimeters instead of using 1/100th of a meter over 1 centimeter. That's what I said. So notice that each conversion factor equals 1, and that's where we're leaving off, and we'll go back to the PowerPoint to go through some examples. All right, so if you had $5, how many quarters is that? So you start whatever they give you, that's what you write down first in your equation to try to solve it. So they give you $5, so you write down $5, and you always write down multiplication sign and then a fraction. Just always write a line because you know you're going to be using these conversion factors, which are fractions. So whatever you start with here, dollar, that unit will go on the bottom of the next fraction. This is always the case, always the case. So that's how you should set it up always. So at least you got that far. You can remember, okay, whatever unit I start with, that's the unit that's going to be on the bottom. And then you know the conversion between dollars and quarters. Sometimes we might not know the conversion, so we might have to convert it to another unit before we convert it to the unit that we're trying to look for. So we have 4 quarters equals $1. So we put 4 quarters on top, $1 on the bottom. In algebra and math, when you multiply, when you have a unit and you multiply by that unit with the unit on top and the unit on the bottom, you can't cross them out. So if we had like 5x, x is like our variable, and then like 3x on the bottom, we can cross out x. So that's where you learn that in algebra. So the dollars are canceled out, so the unit that's remaining is quarters, and that's what we're trying to figure out. So that's why quarters is on top of that next fraction. So 5 times 4, you multiply whatever's on top, and you divide whatever's on the bottom. So you start with 5, multiply by 4, divided by 1, which is going to give you the same number, so we don't really have to divide by 1 at all. So 5 times 4 equals 20. So that's how we do a conversion factor. This is also called dimensional analysis, or you might hear fence posting from other teachers as well. So you can say dimensional analysis, fence posting, because when you make these fractions, they kind of look like a fence. So that's where they get that term. So dimensional analysis is using the units to solve problems. So express a mass of 5.712 grams in milligrams and then in kilograms. So you know that you can just move the decimal point, but using dimensional analysis, we'll have to set up a fraction. So let's see if I can write on here well. So if you have whatever they give you first, which is 5.712 grams, I'll abbreviate, and we're trying to find milligrams. So I told you whatever unit you start with, that's the unit that goes on the bottom. So we can automatically put it on the bottom. Here's grams. And we do know the conversion between grams and milligrams. You can just look at our metric ladder chart up there. So we can put milligrams on top here. Now I told you whatever unit is the largest, you make a 1 because it's easier that way. So looking at our ladder, grams is here, milligrams is right here. So whatever is farther up on the ladder is the larger unit. So grams is the larger unit. So let's put grams as 1 because that's the larger unit and it's easier. Because if you put 1 milligram, then you'd have to do like 1/1000th of a gram, and that's just not fun to work with. So there are 1,000 milligrams in 1 gram, and you know that by just memorizing, like each step is a 0. So like 10, 100, 1,000, and so on. And then it skips to like 3s. So you just add 3 more zeros instead of going a 0 for every step. So 1,000 milligrams equals 1 gram. So that's our conversion factor. So we take 5.712 times 1,000, divide by 1. We don't really have to divide by 1 since it won't change the number at all. So when you multiply by 1,000, you make this number larger by moving the decimal point over 3. You can plug it into your calculator and you'll get it the same way. And that's the same thing when we went by stepping down and moving the decimal point. So the answer will be 5,712 milligrams. And in chemistry, instead of putting commas, they just put a space because it's easier, because sometimes you'll have decimal and sometimes you'll have commas, and it's hard to distinguish depending on the writer. So just a space indicates the comma. So I know the simpler way to do it is just move the decimal point, but we're going to be dealing with numbers that aren't metric. So you can't just always move the decimal point. So they might not be in units of 10. So to learn this, like learning using the metric system by learning dimensional analysis first, you can double check your work so you know that you did it right. So that's why we used metric numbers. All right, so like I said, each step on the metric ladder is a 10 until you get up farther, like going from like kilo to giga and all that stuff is 3 zeros. So there are 10 meters in 1 decameter, 10 milligrams in 1 centigram, and so on. So in your book, you have a problem and you have 5.712 grams. Oh, we just did this one. So it shows you right here how to do it step by step and what we did together. So we put grams on the bottom, 1,000, and they didn't put the 1, but 1 is assumed. So you know that 1 kilogram equals 1,000 grams. This is for the next problem that we didn't do yet. So you can start from the original 5.712 grams, put grams on the bottom. Kilogram is a larger unit, so we give that a 1 because it's easier. We don't have to work with decimal points. And 1,000 grams is equals 1 kilogram. And then you divide by 1,000, which is really moved in decimal point, 3 spots because there's 3 zeros here, and you get 0.005712. All right, section 2, still dealing with scientific measurements. We have to know how to measure before we do any of the chemical reactions. All right, accuracy and precision. This one is really students and people in general always confuse accuracy and precision. So this chart really helps you determine the difference. Accuracy is how close you are to the expected value. So this is like a target, and the expected value is in the center. And when we do chemical reaction stuff, the expected value will be like a certain number. So we want to see how accurate we are in our measurements or in our experiments. So, and then precision is the number of measurements close to each other. So this is precise, but it's not accurate. This is precise and accurate. This is not precise or accurate. This is not accurate, not precise. But they say that this is accurate, even though it doesn't seem so close to the bullseye, but that's what it says. All right, so which one is more accurate, graduated cylinder or beaker? Graduated cylinder has more measurement lines, so it's more accurate. You can be close to the expected value. Okay, that's where we'll pick it up next time.